Thermal electricity generation is the process of producing electricity by converting heat energy into electrical energy. This method is widely used around the world, with many power plants utilizing thermal energy to produce electricity. The process involves using a fuel source to heat water and produce steam. The steam then drives a turbine, which in turn drives a generator to produce electricity. There are several advantages to using thermal electricity generation. It is a reliable and consistent source of energy, as long as the fuel source is available. Thermal power plants can also be built in a variety of locations, making them a versatile option for meeting energy demands. However, there are also some drawbacks, including the potential for air pollution and greenhouse gas emissions. As such, many countries are exploring alternative forms of energy generation, such as renewable sources like wind and solar power. Thermal electricity generation is based on the principles of thermodynamics. It involves the conversion of heat energy into mechanical energy and then into electrical energy. The process uses a heat source to produce steam, which is then used to turn a turbine. The turbine drives a generator to produce electricity. The first law of thermodynamics states that energy cannot be created or destroyed, but only converted from one form to another. In thermal electricity generation, the heat energy from the source is converted into mechanical energy by the turbine. The second law of thermodynamics states that the efficiency of energy conversion is always less than 100%, resulting in some heat energy being lost during the conversion process. The heat source used in thermal electricity generation can vary depending on the location and availability of resources. Some common heat sources include coal, natural gas, oil, and nuclear fuel. The heat energy from these sources is used to produce steam, which is then used to turn the turbine. The energy conversion process involves several stages. The first stage involves the combustion of the fuel to produce heat energy. This heat energy is then used to produce steam by heating water in a boiler. The steam produced is then used to turn the turbine, which drives the generator to produce electricity. Overall, thermal electricity generation is a reliable and efficient method of producing electricity. However, it also has its drawbacks, including the emission of greenhouse gases and the potential for environmental damage. Therefore, it is important to continue exploring alternative methods of generating electricity that are more sustainable and environmentally friendly. Thermal power plants generate electricity by converting thermal energy into electrical energy. There are various types of thermal power plants, each with its own advantages and disadvantages. In this section, we will discuss the most common types of thermal power plants. Coal-fired power stations. Coal-fired power stations are the most common type of thermal power plants. They generate electricity by burning coal to produce steam, which drives a turbine to generate electricity. Coal-fired power stations are reliable and can generate electricity on a large scale. However, they are also one of the largest sources of greenhouse gas emissions and contribute to air pollution. Natural gas power plants. Natural gas power plants generate electricity by burning natural gas to produce steam, which drives a turbine to generate electricity. Natural gas power plants are more efficient and emit fewer pollutants than coal-fired power stations. However, they still contribute to greenhouse gas emissions. Nuclear power plants. Nuclear power plants generate electricity by using nuclear reactions to produce heat, which is then used to produce steam to drive a turbine. Nuclear power plants are reliable and produce electricity on a large scale. However, they also pose potential risks, such as the possibility of nuclear accidents and the storage of radioactive waste. Geothermal power plants generate electricity by using the heat from the Earth's core to produce steam, which drives a turbine to generate electricity. Geothermal power plants are environmentally friendly and do not emit greenhouse gases. However, they are only feasible in areas with high geothermal activity. Thermal power plants are designed to generate electricity by converting heat energy into electrical energy. The main components of a typical thermal power plant include boilers and steam generators, turbines and generators, and cooling systems. Boilers and steam generators are the heart of a thermal power plant. They are responsible for generating the steam that drives the turbines and ultimately produces electricity. The fuel used in the boilers can vary, but coal is the most common fuel used in thermal power plants. Boilers can be classified into different types based on their design and operation, such as water tube boilers, fire tube boilers, and circulating fluidized bed boilers. Steam generators are used in nuclear power plants, where they use the heat generated from nuclear reactions to produce steam. They are similar to boilers but operate at much higher temperatures and pressures. Turbines and generators are the second major component of a thermal power plant. The steam generated by the boilers or steam generators is used to drive the turbines, which in turn drive the generators to produce electricity. The turbines and generators are typically housed in the same building or structure. Turbines can be classified into different types based on their design and operation, such as impulse turbines and reaction turbines. The size and number of turbines used in a thermal power plant depend on the plant's capacity and the type of fuel used. Thermal power plants generate a lot of heat, and cooling systems are required to dissipate this heat and maintain the efficiency of the plant. The most common cooling system used in thermal power plants is a water cooling system, where water is used to cool the steam after it has passed through the turbines. The cooled water is then recycled back into the plant. Other cooling systems used in thermal power plants include air-cooled systems and hybrid systems that combine water and air cooling. The type of cooling system used depends on the plant's location, capacity, and environmental regulations. In conclusion, each type of thermal power plant has its own advantages and disadvantages. The choice of which type of power plant to use depends on various factors, including availability of resources, environmental impact, and cost-effectiveness. Thermal electricity generation produces significant emissions and pollutants that can have adverse effects on both human health and the environment. The primary pollutants released during the combustion of fossil fuels in thermal power plants include sulfur dioxide, SO2, nitrogen oxides, NOx, particulate matter, PM, and carbon dioxide, CO2. To mitigate these emissions, thermal power plants are required to implement pollution control technologies such as electrostatic precipitators, flue gas desulfurization systems, and selective catalytic reduction systems. These technologies help to reduce emissions and ensure that the power plants meet the emission standards set by regulatory bodies. Thermal power plants are subject to strict regulations and guidelines to ensure that they operate in an environmentally responsible manner. These regulations are enforced by government agencies such as the Environmental Protection Agency, EPA, in the United States and the Ministry of Environment and Forests, MOEF, in India. Regulatory frameworks typically include emission standards, reporting requirements, and monitoring and enforcement mechanisms. Power plants that fail to comply with these regulations can face fines, penalties, and even closure. To reduce the environmental impact of thermal power generation, power plants are increasingly adopting sustainable practices. These practices include the use of renewable energy sources such as solar and wind power, the implementation of energy efficiency measures, and the adoption of cleaner technologies. In addition, power plants are exploring ways to reduce water consumption and minimize the impact of their operations on local ecosystems. These sustainable practices help to reduce the environmental impact of thermal power generation and ensure that it remains a viable source of energy in the future. Efficiency improvements. Thermal electricity generation has come a long way since its inception. With the advent of new technologies and advancements in materials, the efficiency of thermal power plants has increased significantly. The use of high-efficiency boilers and turbines has reduced the amount of fuel required to generate a unit of electricity. Additionally, the use of advanced cooling technologies has reduced the amount of water required for cooling purposes. Moreover, the integration of digital control systems and advanced sensors has enabled power plant operators to optimize the performance of their plants. These systems can detect and diagnose issues in real time, allowing for prompt corrective action. The use of predictive maintenance techniques has also reduced downtime and maintenance cost.